Yes.
Fine, sir. How are you, sir?
I'm doing okay. I'm doing fine. All right. So we missed the last class on Thursday,
Sir, how
and
is your mother, sir?
she's doing better. Um, is still under observation, but she's improving. Having some electrolytic imbalance. Sodium was very low, and if you are actually quite old, then it is really very problematic. Maybe for the food habit, or for some other reason that the sodium was going down along with potassium, and the symptom was actually she was not feeling good to eat, or also very weak. The vertigo that is called. So it is unidentifiable as long as you are not doing the test. But she is improving. Let's see that maybe today there is a chance. Maybe they give the release. And the problem in here actually that it's maintaining. It's very difficult because I'm actually now maintaining the house. My wife is in hospital now, and there is no one to come at this lockdown situation. And that's why actually it's very difficult. Anyway, pray for her. I hope that she will be okay very soon. All right. As it is a very eventful week, it should be, as you know that the exam and all other thing. So far, we are instructed that there is no Viva exam. Okay, for the first term, that should be the only the written exam. So that's why I did not put you any schedule, because we were needed to be actually confirm about that. So for the written exam, which date do you prefer? We have classes on I think Sunday, Tuesday, and Thursday maybe with you, right? This section.
Yes, sir.
Yes, sir.
So which day do
After Thursday.
After 6 day, and you will
after
after 6 day.
after
First
6?
day, sir.
Sir,
Um,
Thursday you can pick.
there's a certain problem as well, because I'll not get sufficient time actually to check your script. Let's see. Thursday you prefer, right? As you have said in A.
Yes, sir.
Okay. And what about your other exam? Those are mostly in 5, 6, 7 like that?
Yes, sir.
Yes, sir.
That's why, sir.
That's why, sir, the problem, sir.
There is also some concern. I think the notice came like the exam should be taken from 6th onwards. Okay, so there should not be exam from today or tomorrow as well. I'm not sure, but if it is a pre-announced date, maybe your teacher can take it. And but it is said like from 6th onwards, actually, we should have the exam. And anyway, maybe they can change, or maybe they can continue. So we are planning to take, if I share the screen, so maybe we should go for 8, you said, right? 7 we don't have. Either we can take 6 or 8 maybe. Okay, let's see that you will come to know by a message in the Google Classroom that which date you will be the exam. Okay, and remember the first term exam. Yes,
So I have an exam on 8, sir.
you have exam on 8, not in 8:30 in the morning, right? Because you have a class on that time,
Yes, sir.
so that there should not be any problem. So I did not put any offer. Okay, so whenever I asked you, I try to get the most suitable time for the students on favor of you. If I can take the exam actually on 6, that would be better for me, because I'll get 2 more extra days to check the script and give the result. but still actually I'm taking that pressure only for the some students advantage. Now if you tell like if you have exam on that day, you will definitely have an exam and multiple exam on that day. It is understandable because this is like a term exam, like which happens in the class. So you can have, you should actually manage it. I'm not putting the 6 because I believe that there are many students have many exams on that day. So that's why. All right. So for this chapter, we have finished all that display, flat panel display.
Sir, last class we discussed how does an OLED work.
Okay.
Up to this.
OLED. Okay. So that yes. So we don't have that much left. We'll finish it today, and we'll have another class on 6, so that on 6 maybe we'll start something new. It is up to actually your first term exam will be the before the class that what we have up to that actually will be your syllabus for the exam. So especially these 2 chapters will be focused. If we start something new, we will have something maybe from there. Your exam, written exam, as you know that I have written exam with multiple question set and a little bit analytical. If you have actually exactly same what we have in the slide, someone actually try to write like that, or maybe the multiple students question answer becomes same, then actually you get around 50 to 60% marks of your question what is allocated, even though the answer is right. Okay, so I'm telling you from at the very beginning, better try to avoid. You should write with your own actually idea, whatever it comes in your head, you should write on the basis of it. Okay, do not go for like, okay, I'm asking for OLED to explain, you are actually writing everything from the slide. Definitely you will get 6 out of 10. And if you get 6 out of 10 like this way, then you can see that what actually you can get in the exam, right? So be careful. But if you know what is organic light emitting display, then you write it from your that own understanding, and it will have some hints that this is actually you are writing without seeing anything. Then 1,000 students sit for the same answer and it will be different. Okay, so do not go for it. Your overall grade will be fall down if we have that sharing activity. All right, so some of you already have course with me, so you know it. All right, let's start then with the flat panel display. We have seen so far that this is to categorize active and passive light, and active is light emitting display where the light is actually created, and passive is actually light modulating where the light modulation, that feature has been used to actually display or create the image, which is liquid crystal display or light emitting diode display, that means LED display. And light emitting discharges are commonly the CRT that we have seen, which creates the light, the flat one, then plasma display, and OLED, that actually the last one we are discussing. So CRT, we have nothing new, only the internal structure, which is that the electron gun is parallel to the screen, and that falls 90 degrees on the screen to paint the entire image. All the other activities same. In plasma display, we have seen that plasma is actually a special situation of some specific gas, that ionized gas, which is used actually to create the light. And that is actually, that's why it is called the plasma display, as neon, argon, or xenon are the gases which can be kept in a low pressure and inside a small cell, which we consider as a subpixel level. We have seen in the video. And when we apply the voltage or electricity, then actually the gas that break down the electrons come out and started to actually move here and there. So that's actually the dissociation of the gas, or we can call that is a plasma situation. Now, the reason for using this plasma situation is actually the next moment when the electrons actually go back to their actually that orbit, that cell, that is the recombination of the electrons in that atom. Then there is actually some energy replace that they come out with surplus energy. That is actually the photon, and we know that the gas started to glow. So in plasma display, that is actually quite large, and the resolution is also in the very good quality. If we go for light modulating display now, and if we consider that is actually the liquid crystal display, LCD, and liquid crystal in the different formation, one formation is actually suitable for that LCD to become the polarization. That is actually the nematic form. As we have seen, they are actually jacked one to another. They have actually aligned in such a way that nothing can enter. While the smectic or cholesteric, both are actually having some kind of group-wise orientation, and that's why you might have some gap. So that is actually different formation. So in nematic form has been used with multiple layer of that polarizing sheet, the glass substrate or conductive layer. The main actually technique here for applying that liquid crystal is the light when actually it start to enter in the polarizing sheet through that, because the polarizing sheet are having some specific shape, and that shape say like horizontal or maybe vertical. In this diagram we can see that is the vertical one. So the light enter, and according to that conductive layer which is actually attached the liquid crystal in between the two conductive layer 2 and 4, and as they are according to the polarization, that liquid crystal is nematic form started to have an alignment with that polarizing sheet. If it is vertical, it becomes vertical. If it is horizontal, it becomes horizontal. So when the light enter as a vertical one, then it actually pass through that nematic form of the crystal, because they are nicely aligned, and it bent down from horizontal to, so from vertical to it becomes the horizontal, so that in the other part of that polarizing sheet, which is actually horizontal, the light actually come through, so that it can come through and actually fall on the screen to create the shape. So that is actually, we call it a on state. Now this in this on state, light can actually go through. That's why it is called on. In another form, if these are actually aligned in the nematic way, then the light enter with according to the polarizer, it either take the horizontal or vertical, but it cannot actually move further into that liquid crystal, so that liquid crystal actually block it. So it works like a shutter. That's why it says therefore this crystal works like a shutter. Either it allow the light to go through, or maybe either it actually block it. Now the main thing about this liquid crystal display, as it is calling a passive flat panel display, because it needs a actually light source, and that light source, from there the light actually enter, and that's why there is a problem. Actually the true black color is not possible to generate. Okay, on that video on that day we have seen that the true black color, why it is not possible, because the entire panel in the back side, they actually light up with a fluorescent cathode CCF, that cathode gold fluorescent lamp, has like a tube light. That has been the entire panel is actually light up. Now whenever it is happen that it is light up, so when I have in the signal that blocking some of the light, but still actually that in the behind there is a light, so that's why actually you can see not the pure black. But whenever we have seen in OLED display or some other display, we have seen that that specific part, the light, whenever it is needed to be created or maybe not, then actually we can find the true black color. The difference with that LCD with LED is actually not that much big, because in LED, that is the LED light emitting diode has been used for the light source that we call the LED backlight, and we have seen that that light has been actually flown through that different same mechanism with that LCD display that has like the polarizing sheet for the vertical and horizontal one. In between we have the trapped liquid crystal, and there's some actually extra elements that they put for the display, like a thin film transistor, that a layer for TFT, which help to control the light in more precisely, so that whenever it comes before in here, and according to the signal actually, that it helps to control it, the light. And in the special color filter, so that the light automatically actually get the color to fall on the screen. So that's actually the mechanism for the LED display. The basic difference is actually that the backlight, that is actually the main concern. And for that reason, the LED is more preferable at LED display, because it is actually less power actually energy efficient. As you can see, that need less energy, and also actually less smaller, less weight, and so on. So there are some advantages for it. And then we started the discussion about OLED, our last actually that display, and that OLED as a flat panel, it is an active light display, and we are calling it active because we can understand maybe some way the light will be created here for generating the image. Now, whenever we say organic, we know that organic is actually more or less the good thing, which is more related with the living entities, or actually some other way we understand. But in chemistry, if you have a carbon actually atoms on the outer actually ring, then those are actually organic. And in OLED display, as it is actually called organic, because OLED display has some organic layer inside that panel, which is actually light create at some point and also carry in there. So those elements are actually made with organic elements. So that's why, or polymers. That's why it's actually called the organic display. Now, organic light emitting display, the light emitting diode, the main objective of that diode is actually creating the light or photon. They have a mechanism with anode and cathode activity, you all know. So the same mechanism has been applied here to generate the or create the light. And for that we have 6 common layers. The first 2 layers, like the boundary of it, is actually that same indium tin oxide, that material which is or glass substrate material. One is called seal, one is called substrate. So in between that, the cathode, the negative terminal, has been attached with another part is cathode is actually a positive terminal is attached. And we know that in between those two actually layer, anode and cathode, those 2 of this layer for organic is or polymer based actually 2 layer has been attached. One is actually emissive layer, one is actually conductive layer. The emissive indicate that which will emit the light, okay, and the conductive is actually hopefully that light will be taken away or go through, so that the light output, you can see that from top to bottom has been showing. So as it is top to bottom, here you can see it's actually bottom to up. So the just upside down has been actually moved. The working process when the power is switched on, so the cathode or negative terminal that actually started to lose the started to get the electron, okay, so receiving the electron from the power source as it is actually negative one. And the anode in the same way, they started to losing the electron, so it becomes more holes there, the positively charged. Then whenever the hole, as we know that the very active, they started to cross over and go to the emissive layer for finding out actually from the as the cathode is actually attached with the emissive layer, and anode is actually attached with the positive layer, so that from the anode the holes are actually started to go on the emissive layer, and there the bumping happened, the clash between these two, and wherever that actually it happens in the emissive layer, it is started to glow, or the photon actually comes out, and that actually glow that part, and light is produced. So this is the way actually that when they create the light and actually show the image. We also have seen a video of that OLED, that what actually happens in that, especially in OLED, that we have seen the true black color. This is significant as comparing with the LCD or even the LED. Both of them have actually that limitation, so that if you just compare with one LCD screen, such a big screen like it, or maybe a screen with OLED, so OLED and LED, not the LCD even, you will find the difference. So that not only the difference in about the money that you have to spend for it, but the quality of the picture is actually huge different. So that's why OLED actually provide the true black color, because it does not have any color light source. So that entire panel is not actually light up, only those specific point which is actually needed, that is actually light up. So we have seen one video, right, for it. Have you seen a video for true black color for OLED?
Yes, sir.
Yes, I think so. So that you have seen that in the backlight, that is actually the main difference. So in the backlight is not necessary. So according to the signal, actually pass the voltage, or maybe you are going to get light is produced is there or not. So if it is necessary, then it will be produced. According to that, maybe you have some other mechanism to light up the color source, that which color in the combination it should be. Otherwise, maybe it will be black, means actually complete image. Okay, we are coming back as attendance. So quickly, please, can you come to the video for a while? All right. As I have actually forgot, can you tell me that who was actually on? I think maybe on 8th of June or someday we missed the class. I also could not able to actually take the class for some problem at my home on that moment. I think you can remember that we take that actually afterwards, that class. So who was actually giving me call on that day, on the morning maybe?
So I did call.
Ashik, you did. Anyone else? Because another person was also actually giving me call, maybe for the getting the update. Maybe you were waiting. Okay. Do you have Alif Laila Jannat?
Yes, sir.
Okay, Alif. Did you have your thesis proposal presentation yesterday?
Yes, sir.
Okay. Muhammad Ashikur Rahman Ashik.
Yes, sir.
Okay, Ashik. Muhammad Alamin.
Yes, sir.
Okay, Alamin. Nishat Ara. Nishat Ara. Shohidul Islam Antur.
Present, sir.
Okay, Antur. Sumaya Akhtar.
Yes, sir.
Okay, Sumaya. Arifat Ritu.
Present, sir.
Okay, Ritu. Jinatun Nisa.
Yes, sir.
Okay, you also had the proposal presentation yesterday?
No, sir. Proposal presentation, no. Final presentation.
Final presentation. Maybe I was on that same board?
Yes, sir.
Okay, all right. Parvez Alam.
Present, sir.
Okay, Parvez. Redwan Ahmed Ratul.
Yes, sir.
Okay, Ratul. Salvi Sabah.
Yes, sir.
Okay, Salvi. Jakaria Hassan Pappu.
Sir, he told me to let you know he is very sick.
What happened?
Maybe he got caught catch code
Okay.
which are being favored.
Yes, this week we want no one should fall in sick. Maria Mehjabin.
Present, sir.
Okay, Maria. Israt Jarin.
Presently, sir.
Okay, Israt. Abdul Khalek.
Yes, sir.
Khalek, are you there?
Yes, sir. Present, sir.
Yeah, got it. Ravina Afrin Ami.
Yes, sir.
Are you there, Ami?
Yes, sir.
Okay, found you. Tajnoba Yasin Esha.
Yes, sir.
Okay, Esha. Shahriar Toyon. Mohammad Shahriar Toyon. Hossein Ahmed Antur. Hossein Ahmed Antur. Pratyasha Roy.
Yes, sir.
Okay, Pratyasha. Sharonika Das.
Yes, sir.
Okay, Sharonika. Khadija Rahman Ria. Khadija Rahman Ria. Rahat Islam Rupu.
Present, please, sir.
Rupu, are you there?
Yes, sir. Present, please.
Okay, yeah, got it. Mahmoud Akhtar.
Yes, sir.
Okay, Mahmouda. Didar Al Mahmoud.
Present, sir.
Okay, Didar. Tamanna Tabassum. Tamanna Tabassum.
Yes, sir.
Do you have video, Tamanna?
Yes, sir.
Yes, got it. Saif Mahmoud Sifat.
Yes, sir.
Saif Mahmoud Sifat. Are you there, Sifat? I saw him.
Sir, he is disconnected, sir.
I think he was there. I saw him. Fairuz Tanjim Achal. Fairuz Tanjim Achal.
Yes, sir.
Yes, Achal, what about your video?
Yes, sir.
Okay, got it. Sadiatun Nisa Shetuli.
Yes, sir.
Okay, Shetuli. Mustafa Iram Uday.
Present, sir.
Okay, Uday. Sadia Hussain Mauri.
Yes, sir.
Okay, Mauri. Sadia Akhtar.
Yes, sir.
Okay, Sadia. Sadia, you were absent for a few classes maybe earlier.
Yes, sir.
What happened?
I will see.
You were sick. You are doing better now?
Yes, sir.
Yes, we need, because this is the time actually that all the attendance will be checked now. So if you have some problem like a number of absence is getting high, you should immediately write the email to your teacher, okay? That you have some problem or something like that. Mantakimu Raman.
Yes, sir.
Okay, Mantakimu Atik Faisal Imon.
Yes, sir.
Okay, Imon. Rahul Debnath.
Yes, sir.
Okay, Rahul. Nisha Tasnim Jyoti.
Yes, sir.
Okay, Jyoti. Sadat Mahmud Khan. Sadat Mahmud Khan. Firdaus Hassan Rifat. Firdaus Hassan Rifat. Haja Minhaz Monib.
Yes, sir.
Okay, Monib. Nahida Islam.
Yes, sir.
Okay, Nahida. Hasibul Hassan Shanto.
Yes, sir.
Okay, Shanto. Sharmin Sultana.
Yes, sir.
Okay, Sharmin. Ryan Hussein.
Yes, sir.
Okay, Ryan. Muhammad Alamin.
Yes, sir.
Okay. Muhammad Tariqul Islam.
Yes, sir.
Okay, Tariq. Muhammad Ashiqul Jaman.
Yes, sir.
Okay, Ashiq. Who is having 16103405, the ID? 16103405. Arif Akhtar Ritu, right?
Yes, sir.
Yes, what about your name? What about the
Sir,
profile
I don't
picture?
know. So today's morning I tried too much, but it's not updating, sir. I don't know why.
Okay. All right. So we have absent. Anyone missed on the attendance?
Serial 19, sir. I miss my attendance.
Why you missed your attendance, Antar?
Sir, I am facing network problems, so that's I can't join, sir. I
You
joined
have
late, sir.
you joined exactly right now?
Yes, sir. Just 5 minutes ago.
All right, Antar. We'll check. Okay. Let's come to the point in there. Very basic discussion or the classification, or maybe say comparison, we can say a old comparison, we must say, is between CRT and LCD. As one time actually when the LCD started to take the market, then CRT was actually almost like they were wiping out. There was some significant difference between them. We'll quickly go for that characteristics like the size and weight. This is understandable that who is actually heavy and who is actually are maybe that easily you can carry or maybe take from one place to another place. That display size, the displaying on the screen, that is also actually have some significant difference, like LCD sizes are, just give me a second. So that in display size, LCDs are actually try to give the whatever the define that viewable size, like 17-inch, then the screen almost like in the diagonal, if you try to actually measure, it is 17-inch. But in CRT, it takes little bit extra space. So 17-inch maybe end up that is 16-inch on the screen. Okay. Colors, most of them are capable of displaying unlimited colors. Unlimited in that sense, actually, that much color we can experience. And for LCD, earlier actually had some color issue, but later they are actually capable of unlimited colors. The resolution is actually multiple video resolution. So CRT monitor actually that can adjust with the resolution of their native resolution, and LCD is also actually better in case of resolution, as we started to use in the computing mostly these devices with a different resolution to find out the differences. Then viewing angle, we all know that the computer screen, most of the display are actually flat, and that flat screen are sometimes problem from the viewing angle to check. So from your laptop even you have seen that from some angle you cannot see, but the CRT display, they had this advantage about that little bit of that wider range, so that the viewing angle become actually much wider. Okay. Brightness is not a concern with the CRT monitors. They are actually having what is called the natural brightness, but LCD has actually some brightness that actually you can control, and that has a range with that LCD monitor, 70 to 300 nits for the brightness. And power consumption, this is important. Radiation emission, this is actually maybe one of the reasons that's why the CRT started to be stopped to use the CRT, that mechanism with that electron gun, because it takes actually a big number of power, and also it emit the radiation. That's actually the case. So that's because you have seen that earlier the computer used to get warm a lot, so it actually generates the heat. The price, understandably, the CRT is little bit lower price than the LCD. LCD was expensive at some point, but these days this is actually very cheap, okay, and affordable. The graphics system, we call it is the architecture of the graphics system. Now, this is kind of a logical interpretation. You can find out that how inside the machine in a computing, that what are the components are actually involved to generate the image. Okay, so this is a general structure, as you can see. for the raster graphics. Our main discussion was raster graphics, not the vector at this moment. For raster graphics architecture, this is actually the thing you can find. Like you can find the CPU, which is a processor. You can find the system memory with the system bus and input-output devices. We have the video controller, okay, which control the video. That means the main activity for this is actually the video controller, and then the monitor. So can you tell me that what could be the video controller? Anyone, any guess? With your computer, what could be the video controller? Because you are familiar with all of them, right? You know what is CPU, you know the memory.
Are you talking about the VGA?
I'm telling what could be the video controller. What do you think?
I think that the GPU is mainly the video controller.
Exactly. GPU, even the VGA you have just mentioned, right? What is VGA? That graphics adapter, isn't it? And its main job is actually for the generating the image. So for image generation, for that reason, you see that the extra helping hand for the processor you need. That's actually the video controller. The name, that's why I call the controller. So it takes actually process for the image. Now that double arrow indicate what? For the designing
So
you have used it. Vice versa?
Yes, sir. It can be an input or output.
Input and output, okay.
Yes,
Vice versa,
output, yes.
vice versa is a different way to say, but it might have a flow of communication, and in the both way the communication happens. So it could be sender, it could be receiver, right? We can consider that way. So through the system bus, actually it have an access with the memory and get the image and actually show that in the monitor according to the signal that it is actually coming. So that employs a special purpose processor. You see that it is already mentioned here. It is a special purpose processor called video controller or display controller in addition to the CPU. So CPU itself alone is not actually possible to generate the image unless it get the help from here. Frame buffer can be anywhere in the system memory, okay? Anywhere you might have a frame buffer. You can see the next one is actually showing about that. So from the memory as well, not entire memory is actually dedicated for that image or dedicated for the image generation. Some part is actually, especially we call it a frame buffer, that is, and it is actually that. Now you see that why it is calling frame buffer, because this part of the image or this part of the memory where the information of the image are kept, it will be actually many times, once 60 times in a second, as it is actually checking out and actually going through the video controller to send the signal for the monitor to generate the image. Okay, so that's why the frame buffer as a special part has been allocated. And more sophisticated raster systems employs other processors as core processor and accelerator, so that they also might have some other processor as well, not only the video controller, maybe some other processor, so that actually they can core processor accelerate for the image generation technique. So for raster scan system, we have seen that this is actually the general structure. The next one is actually, that is the frame buffer has been defined with the system memory. That is spatial part has been allocated. Okay, you can see there, but what actually the change do you find in this two diagram? The significant change. The frame buffer, isn't it?
Yes, sir. The frame buffer.
Any changes in the arrow?
Yes, sir.
So, can
directly, right? Yes, that's actually the case. So with this diagram, this is actually identified that directly the video controller takes some actually image information from the frame buffer. They can take it and can generate the image. Also, they are interconnected with the both way with the system memory. So that's why it's called architecture of a raster system with a fixed portion of system memory, okay, reserved for frame buffer. So you can see that this diagram, you need to understand how they're different and what actually are they. There is no explanation you have in the slide, so it is better actually you understand it so that if you come in the exam you can write. We said the third point, like more sophisticated raster system employs other processor as a co-processor, so another processor maybe can be used. So that what actually we have in here, we have earlier the CPU, the memory, and the video controller. We have actually now the memory we have distributed in a special part is actually the frame buffer. The video controller take directly the image from there. Now whenever we are employing a special purpose processor called the video controller, or more sophisticated raster system employs other processor or coprocessor, so that you can see the other processor here. So in the system bus with that display processor, that display processor is actually will have the video controller. That adapter will take the information through the frame buffer. You can see that segmented the display processor, memory, and frame buffer. So whatever the memory we have, this part is memory only for the graphics activity. But what about the other memory part for the computing? That is actually system memory, as you can see that it's been there. Okay. Now the frame buffer we earlier segmented from the system memory. Now we can see that it is actually the frame buffer is part of the display processor memory. Now if it is a special processor, then it might need some special allocation from the memory. Okay, so that's actually this display processor memory, and the frame buffer, the video controller get it from the memory, directly connected with the memory, as you can see, and then can see the image, right? Is it okay that what actually we are doing or discussing? Do you understand, all of you?
Sir, in the first diagram, we saw that the system memory have allocated some memory frame buffer, then goes to the video controller, and in second, the display memory. Why, sir?
Display memory in second means this one you're talking about, frame buffer. Okay,
Yes,
that's why actually I take a pause and asking you, do you think that this one and this one is different? Yes, it can be different for that memory, for that processor only, because this could be a different actually device or element has been added with the system. Now if we go for these two is same. Only this diagram is actually saying that, okay, in your memory definitely you have some part for frame buffer for the image, okay, but when you are actually going for it, now you see that for many games if you want to play, you need actually special graphics card, right?
Yes, sir.
You need some special RAM,
Extra RAM.
right? What is the reason? This is the reason, because you see that the interactivity on your screen for that high resolution with a huge amount of information that you need to access in a quicker time and will display. So you need definitely a strong machine for it. Otherwise this processor will not sufficient to handle it. Right?
Right, sir.
This is all logical now. If you think, then you will find like these are all logical. Now whenever I have a special memory added, processor added to my computer, you see that subsequent memory maybe I have added. Consider that is maybe my extra RAM. And that has actually what? It has the actually instructions that how that processor will work in this machine, and also the information of the images in the frame buffer, which actually the video controller access and can actually generate the image.
Yes, sir. Clear.
Right? Okay. So that this is actually the way we try to logically understand that what happens for the graphic system. That's why it's called the architecture of a raster graphics system with display processor. Okay, it says with the display processor. Now, every cases with these three, at least that the way we try to discuss, which component you find is most important to generate the image?
Frame buffer.
Frame buffer.
So the video controller.
The video controller, exactly. For this activity, the video controller is actually very important, because it actually it has a mechanism for this actually monitor to work to send the image. Okay. Now this video controller we need to actually try to understand how it actually works. So we call it a video controller refresh operation. The basic activity for it is actually, as you can see, that it take the image and try to refresh that on the monitor, so that 60 times it goes on and on and on, and actually you can see the image. So how this activity done in this video controller, that actually we'll try to see in here. You can see here this diagram, that the frame buffer, we know that we need a frame buffer every time the video controller is must attached with the memory. You can see here, so it is with the frame buffer, it is with the frame buffer along with the system memory as well if it is necessary, and the video controller along with the memory as well. So somehow you must have connection, otherwise it cannot get the actually signal for a specific point in there which is stored in the memory. Okay, so for X and Y, two register is there for that video controller. Let us check the mechanism first, that what actually it is. It has actually the frame buffer connected, and here maybe the horizontal vertical deflection voltage that is actually given, that what actually the voltage should be. And this is the raster scanner generator, that when it will be paint, that what is the value it should be with that. Okay, that actually information is coming from the memory, from a pixel register, from a specific point. What actually the information we have, that is actually defined in the frame buffer, so that the intensity, what is the color combination of the intensity it will be, that has been actually defined, right? So that frame buffer, they take that pixel address, and they try to use two register to control, because as you have seen that this is from 1 2 3 like this, so it will go, so like 10, then come back again 1 2 3 4, and the next line 1 2 3 4 like 10 like this, so it goes. Now for every of this pixel I need actually two register to control the values for the X and Y coordinate, then only actually automatically I can move on. So for let us check for this way. So that in the screen, if we have like when it is started to painting, commonly we understand this is maybe from here, right? Then it will go for the second line, then it will go third line, or if they use the odd even cycle, so that 1 then 3 then 4 5 like this way. Now the first one they need to do, then go for the second one, then the third one, fourth one. You see that the coordinate is changing, isn't it? And we know that this is actually our origin point, but consider that is actually the graph for origin point in here, and the X coordinate is going like this way, and Y coordinate is actually going this way. Now for the X and Y, every pixel in here, they needed to be actually have that information, so that we put it in the X register or Y register, that information. So what actually this pixel value should be if my origin point is here? Can anyone tell that what it should be?
Sir, 0 4 maybe.
0 and 4. Okay, 1 2 3 4 as you have corrected, that's good. But we can understand that maybe this is Y maximum, this point is X maximum, isn't it?
Yes, sir.
So that it will be 0 and Y maximum, right?
Yes, sir.
What should be the next one?
Sir, 1 1 Y maximum.
1
Y maximum, right?
Yes, sir.
Right. Then the next one?
2Y
Sir,
maximum.
2Y maximum,
Y
right.
maximum.
So you can see how the changes are happening. What are the changes do you find in that first line when they go for scanning? The changes in the X coordinate, right? Incremented the
Yes,
X
sir.
coordinate. So when I reach in there, that is maybe what? the x maximum and y maximum,
Yes, sir.
right?
Yes.
The maximum value of it. Then it will go to the second line cell again. Then what it should be the value for x and y for this pixel.
Sir, y is decreased from maximum.
Y is decreased from maximum. So the value will be the first one in here is 0, y maximum 1, right?
Yes, sir.
Yes, sir.
Then 1, y maximum 1, 2, y maximum 1. Now you can see that all of them can be actually controlled. As so one is maybe incrementing, one is maybe decrementing, or maybe no change, right? And whenever it is coming like that, like this way, when it reach in there, then definitely the x is actually 0 and y is actually almost like what? That 0, that point. So the last line will be actually 0. So we put also the logic in there that whenever we give the instruction for the video controller, so like you are writing in that video controller, the program for that video controller, how it will work, so that it is in the logic that when your y coordinate value is 0, then actually we go for the x maximum, and the 0, then you should stop, right? Or maybe we can understand that your complete scanning for a one time has been done. Do you understand that what is actually the way? So for if you consider now that how actually it works, you can find here the x register is set to 0 and y register is set to y max. We have just seen now, and the value is stored in the frame buffer for this pixel position is then retrieved and used to set the intensity of the CRT beam. So that the x register is incremented by 1 and the process repeat for the next pixel on the top scan line. So we have seen that this is actually then x register is incremented by 1, then 2, then 3, then 4. The same moment y become y max. So whenever it comes in the last pixel for the top scan line has been processed, that means x max and y max. Then the x register is reset to 0 and the y register decremented by 1. So that whenever you reach on the end, so for the next line, when you come, then actually you increment the x, you have actually the starting with the 0 and the register for the y is decremented by the 1. That's why we made it y max minus 1, right? And pixels along this scan line are then processed in turn, and the procedure is repeated for each successive scan line. So that the next line it goes, and the next line it goes like this, where actually the bottom line, while the y become the 0. And then the video controller resets the register for the first pixel position, that showing that it is done. Now it go for the second time to do the same thing, so that the refresh process starts over, right? Do you understand that how it works? You need to actually draw that screen, and usually we take it on the top corner for the screen, say like in here. So like in the top corner we understand 0 0, but here actually it is considering from this point, okay, from this point, and that's why this is actually that x maximum and y 0, x maximum y max. This is y maximum and x is 0, and this is actually the x is 0 and y is 0, which is the origin. That is the actually way it has been shown in here for the video controller, that working process. All right, do you have any question? The time is up, maybe. Anyone have any question?
No, sir.
If not, on the next day, then whenever we have the classes, we'll finish it up. We'll discuss something about the exam. But your exam, you are going to have maybe 8 years. Someone asked something maybe. Yes, did you have any query?
So it would be better if the syllabus is up to this, like for this second slide. I think if we start any new topic, So
Don't worry. Okay. So if I say like this is somehow good, if I discuss, say like you have an exam tomorrow, so we discuss something today. Now I will try to actually discuss in such a way that it has an impact on the exam. First of all, second thing is actually I will if it is a complex topic that you need a revision, you need actually self study for it, maybe more. Then definitely I'll try to omit that from the exam. Okay, so don't worry about it. I already said your main actually focus will be up to these two chapters. If I start something new, maybe you will have a very small number of questions, something which is without preparation you can answer.
Okay, sir.
Okay, Uday? All right.
Yes, sir. Got
That's
it.
fine. All right. Take care, all of you. I'll see you very soon then.
Okay, sir. Assalamu alaikum.
Okay, sir. Assalamu alaikum.
Welcome, Islam.